Hi everybody. We're going to be continuing our discussion about electrolytes. What are electrolytes? What are some things that are always electrolytes? What are some things that are never electrolytes? And if you're in my Regents chemistry class, these notes start on page 23 and continue going forward in our packet on solutions and solubility. So, electrolytes include three major classes of substances. The first one is ionic substances or salts. All ionic substances are electrolytes. They're not all great electrolytes, but they're all electrolytes. We also have acids and bases, and these are our three substances that are always electrolytes. And let's go into that in a little bit more detail. So an example of an ionic electrolyte or ionic polar substance that would be an electrolyte would be sodium chloride. When sodium chloride is mixed with water, the positive sodium ions and the negative chloride ions dissociate and are then surrounded by water molecules and pulled apart. This is an example of an ionic substance, but I'm also calling it a polar ionic substance because remember, being ionic is really like being super polar. You are so polar that you are no longer polar, you are ionic. And once again, the process by which this happens is called dissociation. Once again, this is that important vocabulary word that we're going to be carrying through this entire section. So essentially what happens is our ions or cations, or positive ions, will separate from our negative ions or anions. And if we look at that in practice, I've taken some sodium chloride, I put that into water, and it dissociates into sodium ions and chloride ions. And obviously, you cannot actually see that happening. That's happening on a submicroscopic molecular scale, but that is essentially what is going on. Remember, ions are elements with a charge, and they result from a loss or a gain in electrons. And also, I'd like you to remember that the elements within a polyatomic ion do not dissociate. Your polyatomic ions will remain intact and act as a single unit. And remember, all your polyatomic ions are found on table E. The more particles something dissociates into, the stronger and better an electrolyte it will be. What I would like for you to do now is determine how many particles will result from the dissociation of these four salts. Take a moment and try to predict how many particles you will get when each of these salts dissociates. So in A, we have potassium chloride. That's one potassium and one chlorine, each one dissociating, and from that we will get 2 particles. In B, we have calcium chloride. Well, we have 1 calcium, but we have 2 chlorines, which means this will dissociate into 3 particles. Remember, those subscripts denote how many of each element are within our substance. In C, this one is a little bit tricky. We have sodium nitrate. This is still only going to be 2 particles because you have sodium and you have the nitrate ion, but that's a polyatomic ion and the elements within it stay together. So that would be 2 particles. And then our last one, we have 2 polyatomic ions, ammonium and nitrate. That will also be 2 particles. So let's talk about some polar covalent electrolytes. Well, your polar covalent electrolytes are mainly your acids. Those are found on table K in your reference table. It's going to be our next unit that we're going to be talking about. The main identifying feature of all acids is they almost all have a positive hydrogen ion within that acid, and when they dissociate, they release that hydrogen ion, and you can recognize that as the first element in each of those acids on table K. The one we say is kind of an exception is ethanoic acid, also known as acetic acid, also known as, vinegar. It still dissociates and releases that hydrogen. However, it's the way that it's written, that hydrogen oftentimes is not shown at the front of the molecule. And if you look, you can see that on table K. So let's do an example. How many particles would result from the dissociation of these acids? So A, hydrochloric acid, that will dissociate into 2 particles. B, because we have 2 hydrogens and we have 1 sulfur polyatomic ion, that one is going to dissociate into 3 particles. And here, in our last one, our phosphoric acid, we have 3 hydrogens and 1 phosphate ion, and that is going to dissociate into 4 particles. Your bases are found on table L, also in your reference table. And the thing that they all have in common is they all have a negative hydroxide ion, or OH ion. The exception is ammonia according to table L. However, when we get into acids and bases, you'll see how that actually kind of does have an OH that is released when you put it in water. It just doesn't come directly from the ammonia. So let's talk briefly about non-electrolytes. Anything that's a non-electrolyte is something that doesn't conduct electricity in water. And I just want to remind you that dissolving and disassociating are not the same. Lots of things can dissolve in water, but not everything disassociates. Most things that disassociate in water are either ionic, acids, or bases. Substances that just dissolve are surrounded by water molecules and hydrated by them, but they do not separate from their member elements within the compound. They do not break down into those disassociated particles. So some examples of non-electrolytes would be organic molecules, which means anything containing carbon and hydrogen. These would include sugars like sucrose or alcohols like glycerol or ethanol. They don't conduct electricity when you put them in water. So that's number 1, organic molecules, non-electrolytes. Our second category that are covalent molecules, we're talking about all nonmetals, if you remember from back in bonding, they're not electrolytes, and our exceptions are our acids. You have acids that are covalent, they are electrolytes. An example of this would be pure water, H2O, it's not an electrolyte. And then symmetrical molecules are not electrolytes, and that's using the SNAP rule. Why would that be? Why would symmetrical molecules not be electrolytes? Well, they don't dissolve or disassociate in water because like dissolves like, and that's because they are non-polar. Okay? Remember, anything that is non-polar will not dissolve in water because like dissolves like. The last thing that I'd like for you to do in this discussion is in your notes, there is a table showing each of these substances. I want you to tell me which ones would be electrolytes and which ones would be non-electrolytes, and also why.